more about matter, this time talking about properties of matter. Property is a word used to describe. In English class, you call these adjectives. We have, in chemistry, two types in terms of properties. The first type is physical, so property that can be observed without changing the material's composition. I can look at something's color, it's not going to change. I can test its hardness by scratching it or something like that. It's still going to be a rock or whatever. Melting, boiling, these phase changes, you're not making anything new. You know, watching a block of ice melt and observing that temperature, it's still water. And the melting and boiling points. Density, we can measure its mass, measure its volume, those objects don't change. And then the last one, solubility, sounds very chemical. Solubility is just, how does it dissolve? And remember, things dissolved, those form mixtures, not chemical bonds. So since there isn't a chemical bond, it's just a physical bond, we're not making anything new here. So we're not changing that composition. The second type of property then is chemical. So these can only be observed by changing the composition of material. Examples, flammability, reactivity, if something can decompose or ferment or something like that, these are all chemical properties. We can describe matter based on whether or not it burns or how it reacts with something. The other thing we're going to talk about today is, after properties is changes. So we're going to look the same. Properties are what we use to describe matter. Changes, this is kind of the action. So the action that we are doing on the matter. Two types, again, physical and chemical. Physical change, we change the visible appearance without changing the composition. We talk about tearing a sheet of paper. Yeah, it's not reversible. I can't put that sheet of paper to get back together, but it's still paper. It just looks a little different. Other examples, boiling, melting, cutting, bending. Dissolving is a physical change. I was looking at the other board here to make sure I got that right on my physical property. Solubility is a physical property. Dissolve means the same thing. It's a physical change. I dissolve sugar in water. I'm not making a new chemical or anything like that. They're not forming bonds. So again, it's a physical change. The other one messes people up, boiling, melting, all of those phase changes, these are physical. It's still water. Just looks a little different. The other part then, the second type is chemical changes. So chemical changes where a new substance is made. Think about rusting, burning, fermenting. When something rusts, that's iron and oxygen coming together to make iron oxide. Burning something, you're taking wood, paper, whatever, you're making CO2, you're making water. To kind of help with this, and in class I'll show you some examples of these in terms of a demonstration, but 6 signs of a chemical change. 1, is it bubbling? Is there a gas being produced? 2, precipitate formation. You've seen a precipitate with the lime water test, those little granules that were made. That's a precipitate. Energy production, so are you heat, light, sound? Those are all forms of energy. Can you see or hear those, or feel them even? More on those 6. So the 4th one, change in temperature. Again, that kind of goes along with heat production, but some things do get cold as well. Number 5, change in color. So if something rusts, it was probably a shiny metal and now it's reddish orange. That's a good one. Copper, it doesn't rust, but it still oxidizes. In this case, we call it patina. It goes from being that really shiny coppery color to the Statue of Liberty. being that greenish patina. The last one, a change in a chemical or physical property. So did something, does it look different? Does it act different? Things like that. Usually a good sign that you made something new, so that it was a chemical change. Kind of have to be careful with this one a little bit. Tearing that sheet of paper, yeah, that was a change in a physical property. So this one, you're probably looking for this and one of the other ones maybe. And the last thing going along with this, we're talking about really chemical reactions. And anytime these things occur, we need to make sure we are conserving matter, or conserving, this can also be law of conservation of mass, if you want to think of it that way. Mass and matter being the same. But during any chemical reaction, the mass of the reactants, so on the left side of our reaction arrow, must equal the mass of your products. So mass here must equal the mass here when you are done. This is true for every single chemical reaction. You get to things like, well, what happens when you burn a block of wood? That wood probably, if it's a big chunk, pretty heavy. When you're done with it, when the fire's all gone, where did all that mass go? It has to go somewhere. There's a little bit left in that ash pile, but we were burning it, so it left as carbon dioxide gas. It left as water vapor, maybe even some soot went into the air, as long as some of that other ash. So it is accounted for. It doesn't look like it. So even something like that can be explained using the law of conservation of mass.